When learning something new, it's often a great idea to compare it against something we know and just build on that knowledge. Well, IPv6's OSPF version 3 does authentication a little bit different than OSPF version 2 for IPv4. So in this video, I'd like to talk with you about those differences. And here's the topology we're going to be using for this lab environment. That's 2001 DB86783, and then for this number right here, it's RR, which is going to refer to the routers lower to higher. So this network segment between R3 and R4 is going to be a 34 there. Between R1 and R2, that's going to be a 12. From R5 to R7, that's a 57, and so forth. Also, for the last number on the IPv6 address is going to be the router number. So R7 will have end in easy for me to say. R7 will end in 7, R8 will end in 8, and so forth. So with IPv4's flavor of OSPF, we had two options of configuring the authentication in the area and then also applying it on the individual interfaces. Well, we still have that same kind of option, except instead of using 0, which is no password, or 1 for clear text, or 2 for MD5, instead, if we're doing authentication, we're going to either do no authentication or we're going to use IPsec. And so what I'd like to do is talk with you about our options there. So IPsec is a framework for encrypting IP packets, and it includes a family of protocols that can be plugged in, like AES, and for encryption, and hashing algorithms like MD5 and SHA. And the way it works is this. We could go to the area and say, hey, for area 0, we want to use IPsec, and we want to use this thing called an SPI, which is an acronym for Security Parameter Index used by IPsec. So we can specify that for the area. We can specify the hashing we want to use, whether it's MD5 or SHA, and then we can also specify a very long key, depending on if we're using SHA or MD5. And once we put that in the area for area 0 on all 4 routers in area 0, this is different than in the world of version 2 of OSPF. With IPv6 OSPF, once we configure that information for the area on each of the routers in area 0, they automatically start using that information on the interfaces. So that means we're doing encryption right out of the gate with that traffic going between the routers. So we have protected encrypted traffic that is now secure. We don't have to go and manually do keys on the individual interfaces. Now also, similar to OSPF for version 2, similarly, we can also just go to interfaces and tell them what to do. So if the area 0 is or is not using authentication with IPv6, we can choose to go in between 2 neighbors and specify exactly what we want to happen. You know, what keys to use, what hashing to use. And regardless of what we have in the area, if we have 2 neighbors on the same segment and we configure them, that will take precedence, and it can still work as long as we have 2 neighbors that are using the same parameters. So what I'd like to do is demonstrate in this video, demonstrate how we can configure the authentication at the area level and also on the interface level. And then in the next video, I'd like to give you an opportunity, if you'd like to get some hands-on practice in actually implementing it. And while my lab is booting up, let me share with you some of the commands, and then we'll go ahead and implement them. So in the area, let's start there first. So in the area, here are the commands we can use. We can go into router configuration mode for OSPF version 3. And what we're going to do is we're going to issue the command area. And then if we want the backbone area, that would be area 0, or if we want to implement it for area 1 or 2, we'd put the correct area. And then we'd say authentication, IPsec, the keyword SPI. We'd pick a number. I think the range is like 256 and higher. We pick a number for the security parameter index. Then for here, we can specify MD5 or SHA, depending on what we want to use, followed by a key of the appropriate length. So these are hexadecimal characters, and we just go ahead and plug those in. So that's how we would configure it in the area. And once we do this, all the routers that we do this on for their area 1 interfaces are going to start using this cryptography. So that's one way to very quickly do it in router config. Now, the other option is we could do it in interface configuration. Let's take a look at that. So if we scroll up here, now for the interface, there's 2 options. We have the OSPF version 3 authentication command or the IPv6 OSPF authentication command. And depending on your gear, it may be possible to do the same exact results with either of these, again, depending on what version of software that you are running. So in the lab, we support both of those. So in the next video, in the next lab, when you want to practice, you can use either of these. Now, the concept is if we configure something like a certain key and a certain SPI in the area, we can override that at the interfaces. And that override includes the option of saying we want to do no authentication with null. So we can accept it on all the interfaces, we can change it to something different, a different key, or just say no authentication, and whatever we have on the interfaces takes precedence. All right, so let me demonstrate implementing IPv6 authentication. And just as a reminder, this is the topology we are going to be using. And I got to tell you, one of the toughest things that, that I have to deal with when going between IPv4 and IPv6 is the muscle memory of remembering to type in IPv6 instead of just IP so we can see IPv6 related information. Because there is IP version 4 also running in this topology, and it's important to make sure we're running the right commands. So we're sitting on R1, who's in area 0. So we do a show IPv6 OSPF and press enter. That's going to give us the details about OSPF, including regarding the areas, are we running any type of authentication? So currently there's no authentication for IPv6 anywhere in the network. All right, so let's enable authentication for OSPF version 3. So we'll go into configuration mode, IPv6, important to remember that. Otherwise, we'll be in the wrong routing process for IPv4 and trying to make changes. It's not going to work. So IPv6 router OSPF1, and in router configuration mode, we're going to type in area, a question mark, and we're going to specify area 0, and then we'll specify authentication, and we'll specify IPsec, and it wants the security parameter index, so we'll do SPI as a keyword. And then it gives us a range of like 256 to a large number. Let's use 100, and we'll use the same command on all 4 routers in area 0. A question mark, and it says, Keith, the range is 256 and higher. Let's use 1,000. That's what I meant to say. All right, we'll use 1,000 in the range, and then we can use MD5 or SHA. So SHA is going to be more secure than MD5. They would both work. So we'll do SHA1 and a question mark. And then we'll go ahead and we'll say 0, meaning what we're about to put in is not encrypted. And then it's asking us for the SHA-1 key, which is going to be 40 characters. So here we go. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 39, 40. I think that's 40 characters. So we'll do a space and a question mark, and then we'll press enter. Yeah, if it wasn't 40 characters, it would complain at us. So we've just woken up cryptography on this device, and then we're going to do that same command on the other routers as well. Let's do a do show history. There we go. So I can just copy paste it right there. In fact, the whole thing. So I'll grab that all. It's in my buffer. We'll go to R2, config T, IPv6, router, OSPF1. We'll paste it in there. And then also, while this is on, let's do a show, and let's take a look at our topology. Let that cook for a second. So in our topology, if we looked at gig 2/0, because we applied it to the area, the interfaces in that area should automatically also be using it. So let's take a look at gig 2/0 from an IPv6 OSPF perspective. So back to R2 we go, and here on R2 we'll do a show IPv6 OSPF interface for gig 2/0, and this just reminds me that I've got a little flutter in my lab here. So when I go into router configuration mode for IPv6, not sure why, it just loses all memory of what it should be able to do. So I'm going to type in exit. And if you're doing the lab in the next lab coming up, and I'll remind you, if you get to a situation where I can't do config T anymore, I can't do anything, just exit, log back in as Bob, and you're right as rain. So let's do a show IPv6 OSPF interface for gig 2/0. And there is our information right there. So it picked this up from the configuration for the area, and now every interface is using it. Now we did lose a neighborship because we have not yet done that command on R4 or R3. So R1 and R2 are happy, but they're not happy with R3 and R4 respectively because they're not using the authentication yet. So we can enable that by going back to those devices. I'll go back to R1, and let me actually grab that command again. And then we'll go back to R3, or go to R3, config T, and IPv6 router OSPF1, paste it in. And once we do that, it should automatically form the neighborship back with R1. Let's make sure that happens here. There it is. And then if we go to R4, and we go to config T and router IPv6 router OSPF1, and we add the authentication there, it should pick up its neighborships with R2 and also with R3. There's R2. Come on, R3. Come on, R3. And I don't see R3. They're both, let's do a show IPv6. Let me exit out and come back in. Show IPv6 OSPF interface brief. And if we look at our topology, oh, looks like we have a neighborship. I'm not sure. Okay, fantastic. So we've got a neighborship. It says here off FA4/1 on R4, which is this interface right here. If we go back and look at it, it says neighbors. The F is the full adjacency, and the slash, the following number is the count. So we are fully adjacent. So that's great. I must have missed a console message. Maybe when I logged out for a minute and logged back in, that could have been. Okay, so that's how we can enable it. Also, if we want to disable the authentication, we could also do that for a link. Let's do that as an example. And let's go ahead and grab our topology. Let's disable it. Let's pick a spot. Let's pick a spot. Let's do it right here. Let me bring up my pen. Let's go ahead and just override the default. So we could actually put a new SPI and a different type of hash and a different key between two neighbors on the interface, or we could just say, hey, you know what, for this neighborship, no authentication is necessary. So let's do it right here on R1, and it's going to be the gig 2/0 and the gig 1/0 interfaces, just as a demonstration of overriding what the default is in the area. All right, 2/0 and 1/0. That's my hardest task here, is to remember which interfaces. Let's start on our R1 interface gig 2/0. So we'll go back to R1, and I'm going to get out and go back in so I have rights here. And config T, interface gig 2/0. Oh my gosh. Oh my gosh. Got distracted. Yeah, 2/0. So make sure I'm on the right interface. And so in that interface config, what we'll do is we'll simply say, we have two options here. We could do OSPF version 3 and then specify authentication null, or we could do IPv6 OSPF, and then we can specify authentication. See how there's similar outputs there? So I'm going to go with the IPv6 flavor, IPv6 OSPF authentication, and then we could do IPsec and set up new keys and different hashing methods, or we could just say null. And we also want to do this on our 3's gig 1/0. So let's do that as well. So we'll go back to the console, go to R3, log back in so I have rights to do this, log in as Bob, config T, and we're going to go to interface gig, and it is 1/0. We just lost the neighborship because they are using no authentication. We are using authentication, and we'll do IPv6 OSPF authentication, and we'll say null. And we should get that neighborship back with any luck, assuming we have the right interface. Survey says, there we go, OSPF version 3, a log message. Great, great, great. And then we can take a look at the interface as well. Show IPv6 OSPF interface gig 1/0. And that's showing us right here the authentication type for that interface is null. Now also, just for fun, if we go to like R2, or any router will do actually that's running the authentication, we'll do a show crypto engine connections active and press enter. Check out these IPsec security associations we have. So from R2's perspective, it has security associations with between itself and R1, and also between itself and R4. So if we go back to the console interface, this represents that. So with IPsec, there's one IPsec for outbound traffic, one IPsec tunnel, or called security associations for inbound traffic, and that's what's being reflected here. We could also issue the command show crypto IPsec SA for security associations, and that would give us a bunch of information on those security associations. And there's one other one that's show crypto IPsec policy, which is another great one. And with IPsec, there's two major families. There's ESP, which is encapsulating security payload, which does encryption, and then there's AH. And that's what it's using right here. It's using AH for the authentication of those OSPF messages for version 3 that are being sent back and forth between OSPF speakers. So in this video, we've taken a look at some of the differences of how OSPF version 3 does authentication for its routing protocol. And what we'll do in the next video is we'll give you a chance to do some hands-on practice in both implementing it and verifying it in the hands-on lab. So I'll see you there in just a moment. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.